Hello and good morning, CTS265 Section 840 students for the Fall 2015 semester at Anne Arundel Community College for the CCNP Route course. Today's video tutorial is going to be on challenge number 3, configure and optimize EIGRP for IPv6. And let's remember, whenever we see this optimize, we need to start thinking about are we going to be doing any kind of summarization? Are we going to be required to set up any kind of stub routing? So again, this is going to provide us with sort of a head start on thinking about some of the tasks that we're going to be asked to do. So our scenario here, you can read through this, and I actually thought this was a little interesting here. It says your company's already tested the dynamic IPv6 routing protocol RIP-NG, and your boss wants you to set up a pilot IPv6 deployment using EIGRP. So in other words, your boss has come to his senses and realized that this is probably not the best option, and that we're going to be taking a look at EIGRP. We've got some basic addressing that's already been configured. We need to set up the dynamic routing and optimize the default settings. So then down here is where we really start to dig into some of the requirements. All EIGRP routes received on the HQ branches must be summarized. So again, when you see this optimize, start thinking summarized. Making the solution scalable for appropriate for larger deployments. Okay, so let's go ahead and let's dig in here. Let's jump on to, let's see the HQ router and see how the HQ router is configured. And I apologize, I've made this text. I received an email from a viewer that said that the text is rather small, and I make it as large as I possibly can within the help menu here. There's a help menu right off to the side, and it says text largest. So I've already done that. Unfortunately, I don't have much more control over the size of the text that you see there. So we're going to go from user exec into privilege exec, and then into global config. I'll say do show run, and we'll take a look at the EIGRP section. And as we would expect, we've got nothing configured right now on the HQ router. So let's go ahead, and again, this is EIGRP for IPv6 is what they're asking for here. The last challenge is named mode, so I'll avoid the name mode configuration here. We'll stick with the EIGRP for IPv6. So I'm going to say IPv6 router EIGRP, and we'll just use 100 as our autonomous system number, keeping in mind that we're not doing named mode. So the autonomous system number here must match between HQ, branch 1, and branch 2 in order for them to establish neighbor adjacencies with EIGRP. Okay, so now that we're into the configuration mode, when we're doing EIGRP for IPv6, we need to make sure that we set our router ID. So I'm going to say EIGRP Router ID, and I was going to set it to 1.1.1.1, do show IP interface brief, or actually IPv6 interface brief. Now it's interesting, you'll notice there are no IPv4 addresses configured. Do I have any IPv6? So the IPv6 addressing is configured. No IPv4. So let's say do show, let's see what it's set to right now, IPv6 protocols. And do we have a router ID? And it does not appear that the router ID, yep, and there it is right there. I was looking further down. Router ID, it says no usable router ID found, right? And we can see that right here. So let's take a look. Do we have to have the router ID set? So I'm not going to set the router ID. I'm going to go to interface Ethernet 01, and I'm going to say IPv6 EIGRP 100. And I'm going to go to the other interface that we have, Ethernet 02, and I'm going to say the same thing, IPv6 EIGRP 100. So if I were to go over to, let's take a look at the diagram here, 01. So if I go to branch 1 on the Ethernet 00 interface, so we'll go from user exec to privilege exec, into global config, do show run, section EIGRP. And again, no EIGRP, but that's okay. We can remedy that rather fast. Router EIGRP 100. And let's go to interface Ethernet 00, do show run interface Ethernet 00. And now there's my IPv6 address. And if I were to say IPv6, EIGRP 100. So let's see if an adjacency forms. Let me make sure I've got that right. That was Ethernet 00. It was, and that's out Ethernet 01. So we're not seeing any messages right now. If I say do show IPv6 EIGRP neighbors, you'll see that what we see as a result is no usable router ID found, right? So no router ID has been found. Let me see if we run the do show IPv6 protocols, do show IPv6 protocols, you'll notice that even though we have the main section here, right? So we see everything that's running here. When we come down to interfaces, even though I've configured it on Ethernet 00, that is a terrible E there, and that's even worse. Ethernet 00, try to fix that a little bit. Ethernet 00 doesn't show up here because EIGRP for IPv6 is not only not going to establish an adjacency, the reason it's not going to establish that adjacency is because it's not even going to run the process on the interface on which we have configured it, because there is no usable router ID. So we need to make sure from a configuration perspective that when I say IPv6 router EIGRP 100, that I set my EIGRP router ID. And for branch 1, here's what we'll do. For branch 1, I'm just going to go ahead and use 1.1.1.1. So now let's say do show IPv6 protocols. And sure enough, take a look right here. As soon as I entered the router ID in, boom, EIGRP is up and running on Ethernet 00, and I have my router ID. Now, when I take a look at my metric weights for bandwidth, delay, load, reliability, do I have a K6 equal 0? No. So if you do not have K6 equals 0, you are not running in named mode. You are running in classic / autonomous system mode, because we end at K5 here, right? All right. So let's go ahead, and we've got our router ID here, but still do show IPv6 EIGRP neighbors. Any neighbors? Still no neighbors. And the reason is, remember, on the HQ router, we did not assign a router ID. So let's resolve that right now. So I'm going to say IPv6 router EIGRP 100 EIGRP router ID. So for branch 1 and 2, we'll use 111 and 222. So here, what we'll do is I'll just simply say router ID, and we're going to go ahead and set this. Let's see, I guess we'll just use 3.3.3.3. It really doesn't matter. Again, it's going to be an IPv4 formatted value. And as soon as we enter that in, take a look at what happens. So the diffusing update algorithm, we get a syslog message, neighbor change, EIGRP for IPv6, AS100, and there is the neighbor. Now again, I'll bring it back here. We're learning about that neighbor out interface Ethernet 01, and this is our local interface. We have a new adjacency. However, you can see that the neighbor, we have this adjacency with the link local address here. Not too convenient, right? So what we'll do is we'll go into interface Ethernet 00, and I'm going to go ahead and say IPv6 address, and this may or may not be required. And we'll do ::1 for branch, link local, for branch 1. All right. So now this is going to take the adjacency down, and it's going to bring it back up. And the reason it's going to do that is because we've got a new link local address. So if I come over here to HQ now and rerun that same command, not the router ID command, do show IPv6 EIGRP neighbors, you can see that we've got a much easier address to deal with here. And so I'll do the same thing on the HQ router. Let's go into interface Ethernet 01, and we'll say IPv6 address FE80::3 link local, and an interface Ethernet 02, I believe it was, and we're going to say IPv6 address FE80::3 link local. Now remember, the link local address is locally significant on the link, right? And by link, I mean on the interface. So on the HQ router, you'll notice that I put in on Ethernet 01 and 02 the same link local address, and that is 100% okay to do. All right, and again, this is going to help us down the road when we look at our show IPv6 EIGRP Neighbors command to see or to decipher which neighbor we're learning that information from. Again, if that link local address had popped up as the FE80 with just some random string of characters, we'd then have to depend here on the interface to help us out. We'd have to know what interface we're looking at there. All right, so we've got it set up now, the EIGRP adjacency established between HQ and branch 1. And let's go back to the diagram here real quick and take a look, because what we have is we also have two loopback addresses here on branch 1. And my guess is we need to get these guys into EIGRP so that we can see that the routes are effectively being learned. So I'm going to step back over here to branch 1, and let's say do, and I thought I'd actually already set that. We did set that. Let me see here. Let's do Control U. So we're going to say do show IPv6 interface brief. Let's take a look at our IPv6 addresses here. And what do we have? All right, so we do have a loopback 0, and we do have a loopback 1, again, with some random EUI64 calculated link local addresses, and that's okay for these loopbacks. We're interested in their global unicast addresses. So we'll go into interface loopback 0, IPv6 EIGRP 100, and go into loopback 1. Same command, and this is going to enable the EIGRP process on those interfaces, and it's going to originate those routes into the EIGRP autonomous system that we're working with. So let's go ahead and go back to HQ. Let's confirm, am I picking up those routes if I say do show IPv6 route EIGRP? And absolutely, we've got the two loopback addresses 16 and 17 off of the branch 1 router, and we can see that this is the successor route. There is the successor FE80::1. Again, much easier to figure that out, and we know right away, hey, that's branch 1. And we know it's going to be out our local Ethernet 01 interface that we need to go for the next hop. All right, let's clear the screen here. So it looks like we've got branch 1 so far, no summarization yet. They may ask us to summarize these. We may end up summarizing these, but we'll see what happens here. There might be another obvious summary, and it looks like we may be summarizing in both locations. And so they do ask to summarize all. Okay, so all EIGRP routes received on HQ from the branches must be summarized. So let's go ahead. Let's deal with branch 1 right now. We need to summarize the global unicast addresses here that are on loopback 0 and loopback 1. So what I'm going to do is I'm going to create some space, and we're going to switch our color here to yellow, which really kind of pops off the black here, and we're going to go ahead and do our summarization. So IPv6 summarization, we take a look at the hextets, right? I'm looking for the interesting hextet. So again, same, that's the same. So the fourth hextet, bits 49 through 64, we find our interesting hextet because we've got two different values. So now let's remember that we're using the rule of zeros here, one of the rules of 0. And what do we have is we've got In that hextet, we have 2 zeros. I'm going to put the hexadecimal characters here before we go from hex to binary. So what it would read in hex is 0, 0, 1, 6. Now remember, this is hex, because we've dropped the leading zeros that should be right there before the 1 and the 6. Now, what I want to do is I want to convert the hex into binary. So I'm going to convert it into binary. And what I'm going to get for the 0, I obviously get 0, 0, 0, 0. And then again, 0, 0, 0, 0. For the 1, we're going to get 0, 0, 0, 1. And then for the last hex character, we get 6, which is 0, 1, 1, 0. Because again, remember the values of these positions are 1, 2, 4, and 8. So here is a bit breakdown of the 4th hextet and each of the hex characters. So it looks like we may be going deep dive here into the binary, or I'm sorry, into the bit level for our summary here. So that is the first route. Let's take a look at the second one where we have 17. So again, 17 would be, and I'll do it below here, in hex, we're going to see that it's going to be 0, 0, 1, 7. That's what we're presented with above. But in binary, what is 0, 0, 1, 7 going to look like? So if I say binary, well, the zeros, we know those. Those are pretty easy. 0, 0, 0, 0, and then 0, 0, 0, 0. Now, the 1, same thing, 0, 0, 0, 1. And now we have the 7. Well, keeping in mind that it's 8, 4, 2, and 1, it would be 0, 1, 1, 1. So we are definitely going to have to come into the bit boundary. We can't do it at the nibble. Remember, 4 bits is a nibble, right? So we can't do it at the nibble boundary here. We're going to have to go into the bit boundary. So I see that we compare the bits now. Those are all the same. These are all the same. These guys are all the same. And when we get into the last nibble is where we see that bit is good, or the same. This one is the same. That one is the same. However, it is right here, and I will flip over to red here real quick. It's right there where those are no longer matching. So we have these last bits here, the low order bits in, excuse me, in the value for that hexadecimal character, right, for 7 and 6 that no longer match. So let's go ahead. We're going to get our prefix length right away. So I've got 2001 DB8:0. So I already know that the first 3 hextets, which each have 16 bits, match. So we've got 48. Then I come into the 4th hextet, which are bits 49 to 64, and what do we see? Well, those 4 match, these 4 match, these 4 match, and 3 of these guys match. So 4 plus 4 plus 4 plus 3 is going to give me 15. So 48 bits and then an additional 15 bits match, and that's going to give me, what is that going to give me? 63. So my prefix length, I can tell you right now, will be a /63. Now, this final step is where we need to be very, very careful, because when we look at these values here, remember, these are binary. So we went from hex to binary to figure out the bit level boundary for my /63 prefix length. However, now I need to make sure that I go from binary back to hexadecimal when I'm configuring, excuse me, when I'm configuring my summary. So I need to make sure I know what these 2 values are going to represent. So 4 and 2 will represent 6, but it's not the decimal value 6, it's the hexadecimal value of 6, right? So again, it's going to look kind of straightforward. So it would be 2001 DB8 colon, and it looks like we've got is a 0. Yeah, colon 0, colon. Now remember, this value here was on in the 1 position as well. So it's going to be colon, we would put 2 zeros. So this guy would be 0, 0, 1, 6 is what it would look like in hex. Because remember, I've got to convert these binary bits back to hexadecimal. So 0, 0, 1, and 6. Okay. Now, where this could get tricky, and I'll go ahead and finish it out here. Colon, colon, /63. So that is my summary on branch 1. Now, a quick sidebar here. Where this gets tricky, right? So here it was easy because the bits, the binary values, converted back to the correct hexadecimal representation, which appears to be a decimal 6. It is not. Remember, these characters here are hex values. Where this can get tricky is, let's say that bit value was on and this bit value was on. So now we have 8 plus 4 plus 2. And 8 plus 4 plus 2 is 14. And a common mistake that gets made is that new learners will look at those bit values and say, oh, okay, so it would be 0, 0, 1, and then maybe put the 4 for 14 or drop in an extra 1 to represent 14, when that is not what we're doing. We're not going from binary values to decimal values. That's not what we're doing. We're going from binary to hexadecimal. So the last hex digit that looks like a decimal is 9. Once you go to A, the equivalent decimal value is 10. B is 11, C is 12, D is 13, E is 14, and F is 15. So, if we're looking at this, what would be the value that I would put in here instead of this 1, 4 right here? It wouldn't be this. It would be 0, 0, 1, echo, right? And again, remember, 9 is 9 in decimal. If this is our decimal values over here, 9 in decimal is 9 in hex. However, that's it. As soon as decimal moves to 10, it's A in hexadecimal. B is 11, C is 12, D is 13, E is 14, and F is 15. Because if all of these values are on, right? If all of these bit values here are on, we have what? 8 plus 4 plus 2 plus 1. So we've got 12, 13, 14, 15 is the highest number we can ever have, and we know that in hex, that's an F. All right, so again, be very careful when you're doing your conversion from binary back to hexadecimal, that if you end up with a large value like a 14 or a 12, remember, you need to then do the final step and convert that to hex to get the proper value, which is going to be, or would be, E. All right, so we have our summary here for branch 1. Let's go ahead and put this into play. I'm going to clear the screen. If you wanted to screenshot that, do it now. So let me clear the screen here. So we're back on branch 1, and do show IPv6 interface brief, and we are out the Ethernet 00. So again, to perform the summary for EIGRP for IPv6, just like EIGRP for IPv4, remember, those are not named mode. They're different than named mode. So for EIGRP for IPv6 and IPv4, we go under the interface, and this is where we say IP summary address EIGRP 100, and then, and in fact, let me catch myself here. I've done this before. I get caught up in IPv4 mode. So IPv6, and let me go ahead and just pull this back, we'll say Control C here. So we'll go into global config again, into interface Ethernet 00, and I'll say IPv6 summary address EIGRP 100, and then this is where I put in my 2001 DB8:0:16, again, because the rule of zeros allows me to drop those preceding zeros, :/63. And I'm trying to recall, I want to make sure that that was right, and yes, that had to be correct. Okay, so there is my summary. No leak map here, right? Just a summary. Now we're going to have a graceful resync/restart of the process. If I come over here to HQ, there we go. There is our pure graceful restart. So let's confirm. Do we have optimization via summarization on the HQ router? Is he only learning a single summarized route? So do show IPv6 route EIGRP, and 100%. I'm learning a single EIGRP route from the successor branch 1 out my local Ethernet 01 interface, and there is the successor route. And you can see we have our /63. So let's do some validation real quick. Let's make sure that we can reach both of those addresses. So 2001:DB8:0:16, and now I don't remember, is it just a 1 at the end on those IPs? Yeah, ::1 for both. Okay. So 16::1, perfect. And then 17::1, do I have full reachability? We do. All right, so we know that our summary address is working. On branch 1, if I were to do a do show IPv6 route, you can see that we have a very important new addition here to our routing table. It is an EIGRP route to null 0. Now remember, what is that null 0 interface for? Exactly, the null 0 interface is for any routes that show up on, or any traffic that shows up here on branch 1 that is destined for a route that would fall inside of this summary that we do not have a route for. So if I had traffic coming in for 2001:DB8:0:, and we'll just say it's 19::/64. If there was traffic that showed up, you'll see I don't have a route for anything that matches this. Although, if that fell within this summary range, this is where HQ would send the traffic, because that's what HQ knows about right now, is he has a summary that this prefix link falls within this range for. So what would happen is it would get sent to null 0, which is the bit bucket, right? It would just simply drop that traffic, and it's going to go into the bit bucket, and this prevents routing loops. Specifically in the case where if branch 1 had a default route that pointed right back to the HQ router, we would be in trouble, right? Because branch 1, or I'm sorry, HQ would send the traffic for the :19. Branch 1 would say, nope, I don't have a route for that, but I do have a default route, and it points back to you, HQ. So it would send it to HQ, HQ would send it back to branch 1, and that would go on ad nauseum, right? We'd have a routing loop until we hit the max hop, which is 100 by default. But of course, that is definitely not optimized. That is what we call suboptimal. All right, so we'll clear the screen here. So we're good between HQ and branch 1. Now let's go ahead, let's transition back over to branch 2. We want to take a look at branch 2 next. So on the branch 2 router, we'll go from user exec to privilege exec into global config do show run section EIGRP. We're anticipating exactly that we have no configuration on branch 2. So I'm going to go ahead and say IPv6 router EIGRP 100, and excellent, this is great, right? The other two had IPv6 unicast routing enabled. It's not enabled here, so what do we have to do? IPv6 unicast-routing. So I love when they do this, again, forcing you to think about it, because if you're jumping on a router that's brand new out of the box, or maybe one where you've wiped the config, these are the things that you've got to think about when you're doing your configuration. So now I'm going to come back with my IPv6 router EIGRP 100. Want to make sure we get our EIGRP Router ID defined. I think we said for branch 2, we're just going to go with 2.2.2.2 to keep it simple. And that's pretty much it right here under the global EIGRP config section. Do show run section EIGRP, where we've defined our IPv6 router EIGRP 100 as well as the router ID. And remember, we've got to have that router ID, or else not only is it not going to establish a neighbor adjacency, an EIGRP adjacency, but it's not going to do it because it is not going to enable the EIGRP for IPv6 process on any interfaces, irrespective of whether or not we go to the interface and say IPv6 EIGRP 100. We have to have the router ID in there. It will not do it without that router ID with EIGRP for IPv6. Okay, so we've got it set here, and now let's go ahead and do show IP interface brief. I want to check the interfaces real quick. So yeah, we've got 3 loopbacks and we've got 1 interface facing the HQ router. So let's go ahead and make this happen. Let's say interface Ethernet 00, IPv6 EIGRP 100. Let's spell EIGRP correct. Interface loopback 0, I can go up arrow, then there you go. We've got our adjacency. I can go interface loopback 1, and we've got our setting there. Interface loopback 2, IPv6 EIGRP 100. So now we've got everything configured. The last thing I want to look at, do show run interface Ethernet 00. Yeah, let's jump in there, interface Ethernet 00, and say IPv6 address. And I don't believe I did this already on 2. Branch 2 link local. Let's make it FE80::2. And that way it's a little easier for us to decipher some of the output there on the HQ router. Okay, so if I were to say do show IPv6 EIGRP neighbors, I should see 1 entry. We know that FE80::3 is going to be the HQ router. Again, we've got the handle column that shows us the numerically ordered, the numerical ordering of how or when the neighbors were learned. So HQ is going to be our first entry. We've got the hold time, which shows us the countdown from 15 seconds, and we get our hellos every 5 seconds. We've got the uptime, if it's been up for 10 seconds. Smooth round trip time, right? How long it takes a packet to go to the HQ router and back in milliseconds. And then we've got the retransmission timeout interval of 156 milliseconds. Typically, SRTT is if you multiply that by 6, you would get your retransmission timeout. Although you don't see that here, that's actually in an amazing book by Don Slice and some other individuals. I think it's just EIGRP or IP routing with EIGRP, where it talks about that smooth round trip time being 6 times. If you multiply it by 6, you get the RTO value. Okay, so we're set up here. We know we've got one final thing that we're going to need to do. So, and that is we've got to optimize, right? If I go over here to HQ, let's take a look at the do show IPv6 route. And now we're kind of littered here with 3 additional routes that we're learning from branch 2. So we want to do some summarization over here on branch 2. I'll say do show IPv6 interface brief, and then we'll create some room for us here. And now we're going to tackle the summarize. Oops, sorry about that. We're going to tackle the summarization here on branch 2. So I've got the loopback 0 address, I've got the loopback 1 address, and the loopback 2 address. The loopback 0 is right there, just scrolled off a little bit. So when we look at these, we'll move a little quicker here. So we've got 30, 31, and 32. We know that those are the interesting hextets. And in fact, we know that in this nibble, those values match. So do I really need to write them both down? Probably not. So I'm interested in the low order, or I should say the low order, or I should say just say the nibble. I'm interested in this final nibble here. So 0 in hex is equal to 0, 0, 0, 0. 1 is 0, 0, 0, 1. And the binary value here is going to be 0, 0, 1, 0. So this equals 0, this equals 1, and this equals 2, right? These are the hexadecimal values, and these are my binary values. Whoops. Kind of stop. Right, oh, look, we may be losing desk scribble here in a second. It's been crashing lately. So those are our binary values. So when we take a look at these values here, these binary values that we have, we can easily decipher right away where are they no longer. Let's get desk scribble back up here. Where are they no longer the same? And I'll rewrite those out real quick here, and I guess it's going to be a little thicker. 0001 and 0010. We can clearly see, slide that over and bring this to yellow, we can clearly see that they no longer match right there. So we know that the first hextet matches, the second hextet matches, the third hextet matches, so that's 48 bits right there. Then the first two zeros match, that's 8 additional bits. That nibble matches with the 3, that is 4 bits. Then we've got 1 and 2 additional bits, right? So we've got 6, 14, 22. We carry the 2, and we've got 62. So the prefix length we're looking at right now is a /62. The last question we need to answer is, all right, well then what is the global unicast prefix? Well, that's going to be 2001 colon DB8 colon 0 colon, I'll put the zeros in here, right? So 0, 0, 3, because we know right up to that nibble, everything matched except the last nibble that we had here with the 0, 0, 0, or the, I'm sorry, with the 0, 1, and 2 in hexadecimal. In binary, they stop matching here, so it's going to end up being a 0 because, again, these last bits that match, we have no values that are on. There are no 1s here, so nothing's on. So it's 0030 colon /62. Right? Now, we're going to drop these out when we go to do it, when we make our entry, but I just put them in there for clarity because I want to make sure that we were addressing those since we were talking about the rule of zeros, right? So that is going to be the summary. So I'm going to clear the screen here. And we're going to come back to branch 2. So let's go ahead and on branch 2, let's optimize here. So that's going to be interface Ethernet 00. I'm going to say IPv6 summary EIGRP 100. And now I'm going to put my address in, 2001 colon DB8 colon 0 colon 30 colon slash and 62. So we're going to have a graceful resync here. I'll move over to the HQ router. And again, remember, EIGRP distance vector, I can summarize anywhere in the topology. All right, so what is my routing table? And let's even trim it down further. What does my routing table look like now for IPv6? You've got it. We have 2 entries here, right? Both summaries, one a /63, one a /62, both administrative distances of 90. Here is their calculated distance. The successor route, here is my successor, right? So this goes to branch 2, this one goes to branch 1. Again, very easy to tell here. Ethernet 1 goes to branch 1, Ethernet 2 just happens to go to branch 2. Those are my local interfaces out which I'm learning about these summaries. And so that definitely meets the requirement we had over here. And let me switch this quickly to red. Definitely meets the requirement that I had over here that all EIGRP routes received on the HQ branches must be summarized, right? So we have achieved that, so we'll give that a big check mark. Let's clear the screen. And now we're going to take a look. Branches also need IPv6 internet connectivity through HQ, which is, okay, default static route. So this is going to be very straightforward here. To reach it should be announced to the branches in a dynamic manner. So what do you think they're saying here? That information on how to reach the internet should be announced to branches in a dynamic manner. Well, dynamic, we're talking about routing protocols, right? What routing protocol are we using here? EIGRP. So we should be very quickly thinking to ourselves, I need to create a static route on the HQ router. Static. Need to create a static route. I need to redistribute that static route. Redistribute. Sorry about that. Some spelling challenges. We need to redistribute that static route, and we need to do it in a dynamic fashion. Well, we just happen to be running EIGRP, so there we go. All right, so let's tackle this right now. So I'm on the HQ router. Let's go ahead. We're going to do a IPv6 route. We're going to create an IPv6 static summary route, or not static summary, static default route with the ::0. Remember, that's the equivalent to IPv4's quad zeros. And what is my next hop going to be? And let me see if I have that up here. It's going to be directly connected. Let me take a look at the interfaces again. I can't remember all these interfaces. Ethernet 00. All right, so Ethernet 00 should be 2001:DB8. Let's just go ahead and take a look. Let me pull this back real quick and say do show run interface Ethernet 00. So it's going to be .1. My guess is on the other side it's going to be 2001:DB8 :100::2. Yeah, so it's got to be 2 on the other side. Okay, so let's go ahead and add in that static route now. So IPv6 route, and the equivalent is : :/0 for IPv6. What's my next hop? 2001:DB8 :100:100:2. So again, that's the next hop IP address of the router on the other side, the internet, quote-unquote, internet router. So now that I've defined my static, how do I get this into EIGRP? For IPv6, exactly. IPv6 router EIGRP 100. And I'm simply going to say redistribute static. And that's it. So let's check, do a quick confirmation here on branch 1. Go from user exec to privilege exec. And actually we can do it from privilege exec. So I'll just say show IPv6 route EIGRP. So have I learned a default route via EIGRP for IPv6? I absolutely have, and here it is right here. We can test this. I should be able to ping 2001:DB8 :100::2. So I've got full reachability right now to the internet. If I say show IPv6 EIGRP neighbor detail, what do we see? We see the same information that we've seen before, right, from branch 1. And actually, I'm more interested in the show IPv6 protocol, where we want to see that we are summarizing, right? So here is my summary. Everything looks great there. We've got the router ID for branch 1. Right? So everything looks good, and I have reachability to the internet. If I transition to branch 2, let's do the same confirmation. I can say end. I can say show IPv6 route EIGRP, and there is the default route. Can I ping? Do we have reachability? 2001:DB8 :100::2. So I've got full reachability. Show IPv6 protocols. My summary should be there at the bottom. I've got my router ID. Everything looks great. Final confirmation here. We'll go to HQ, and I believe this is probably the last thing that we would have had to have done. I think everything else is done as part of this discovery or this challenge activity here. So I'm going to say end. I'm going to say show IPv6 route. Am I learning the summaries? Let me trim this down here, EIGRP. So there we go. We saw that. So show IPv6 protocols. And you can see that we are redistributing static. The protocol static is being redistributed. I've got my router ID here. Again, no case 6 value. So we are not doing named mode, right? I can load balance by default over 16 paths. The maximum hop count is 100. Variance is at its default as well. And so this is it. This is going to wrap up. I believe that we've met every criteria here for Challenge 3, configuring and optimizing through summarizing EIGRP for IPv6. All right, thanks for watching. I hope this has clarified any EIGRP for IPv6 questions you might have had on this activity, and I will see you all on Monday.